Hello, hello. Can everyone hear me? I think there's only Louis watching the stream right now, so. Okay, well, I think we're going to be starting, and if people join, well, they'll be joining afterwards. So, hi everyone. My name is Jack, and today with Louis, we will be exploring the frontiers of AI. This presentation will be a summary of a conference given by the Global Google Student Developer Club. So, first of all, we're going to talk about AI and machine learning, and then we will go through some products offered by Google. So, the goal of today is to introduce the concepts of AI and machine learning for people who have never worked or very little on AI. So, today it's very easy to get lost when starting to get into AI. We have so many new technologies we can get our hands on. At Google, they split AI and machine learning products into three main categories. We've got model first products, which are used for building the model and require specialized skills and data. For example, we have TensorFlow or Keras. Then we've got API first products. These are emerging quickly today and are traditional dev toolchains products. And finally, we have prompt first products. These are the products for the these are the products for the users. They do not have an API that you can build an app from, and you have to use them through the user client. So first, we will cover what is machine learning, how does it work, then neural network and deep learning, and finally, we will briefly introduce products around model first area. So what is machine learning? When you first get started in this topic, all the terminologies are quite confusing. AI, ML, deep learning, Gen AI. AI for artificial intelligence is the bigger concept, kind of the superset that includes all the methodologies to implement. Among one of them is ML, machine learning, which has been emerging recently. The main concept is machines that try to become smarter. Then among machine learning, we have deep learning, which is one of many ways of doing ML. And today, many of you have probably already heard of Gen AI or generative artificial intelligence exclusively with ChatGPT. So this diagram is very important to remember which is the superset of which and help you understand and remember the different terminologies. So, what is machine learning? In summary, you have a computer called model to which you give an input and then use the output. And honestly, that's pretty much it. And it's quite reassuring to be able to understand such a strange concept, but in such simple but powerful way. So, as an example, you have all already programmed in your life, and you know that you have to cover all of the different cases so you can explicitly tell the computer how it should react in this specific situation. But now, let's say you're dealing with spam emails and you want to implement a spam filter with if and else statements. Well, you'll never be able to keep up with all the different types of spam emails that exist. And this is why machine learning is used. The computer will react without you explicitly telling it what to do to a unique email. If we take Gmail, for example, you can mark a certain type of email as a spam. Then, in the future, you should not get the same emails again, as you will have, in a way, trained the Gmail spam algorithm to detect them. So, machine learning is all about patterns and then data. The computer will search for patterns in the data to get the wanted output. So, how does machine learning actually work? There are a lot of different ways of implementing machine learning. On this slide, you can find a few: supervised, unsupervised, semi-supervised, and reinforcement. But we will only be covering in this presentation supervised and unsupervised ones. So supervised and unsupervised are two main ways of classifying machine learning. So supervised, the machine is trained on what we call labeled data, data that has tags. The goal is for the model to learn the mapping from inputs to outputs. In this example, as you can see on the left of the screen, we have images with the labels of cats, dogs, mugs, and hats. While on the other hand, unsupervised learning is when the machine is given data without explicit instructions on what to do with it. The goal is to find hidden patterns or intrinsic structures in the input data. We then talk about unlabeled data. For example, if you want to classify articles about sports or politics, you know that articles do not all follow the same patterns but have the same meaning behind, or the same topic. So, the key differences to remember. For labels, in the supervised way of learning, you have the labels are with tags. We use labeled data. And for the unsupervised, the data is unlabeled. So the goal of the supervised learning way is to predict the output based on input data, and for unsupervised is to discover the underlying structure or patterns in the data. Common algorithms for supervised learning could be linear regression, logistic regression, or softmax regression, and many more. And for the unsupervised learning, we have k-means, clustering, detection, and many more. For this presentation, we will only be focusing on linear, logistics, and softmax regression in the supervised learning. So, linear regression. Linear regression is a supervised learning algorithm used for predicting a continuous target variable based on one or more input features. It models in some ways, it models the relationship between the input features and the target variable by fitting a linear equation to the observed data. All this could seem quite complicated, but it's quite simple. If we take the leftmost table on the screen, according to the number of classes you attend in the year, your final grade will depend on it. For example, as you can see, if you attend no classes at all, you will probably get a 0 and fail. However, if you attend 7, 9, or 10 classes, you see that the score has a linear progression towards 100. For logistic regression is a supervised learning algorithm used for binary classification tasks. It predicts the probability that a given input belongs to one of two possible classes. So you can see that the only two outputs are possible in this second example is yes or no. Here, depending on the tumor size, we can detect if it's likely to be a cancer or not. And finally, for softmax regression, softmax regression, also known as a multinomial logistic regression, is a generalization of logistic regression and linear. It's some sort of mix between both. As you can see here, according to the hours studied for your final exam, the grade you will get will depend on it. We are now only going to focus on linear regression. Let's say we have x as an input and y as an output. For the table on the left, in this table, The output is easily predictable. As you can see, if we put in 0, we will get out 0. 2 will get out 2. So it's very easy for you to predict that if x would be 5, then y would mostly be equal to 5. But our world is not exactly that way, and it's more like the data in the right table. If x is 0, then you would want y to be 0, but that's rarely the case, and it's much harder for you as a human to be able to predict, for example, what the output of x equals 5 would be. To solve this issue, we could draw them as shown in this image. We have an x and y axis, and we input the numbers we were given in the previous tables. Then it's just what we call a drawing game. We have straight lines which could give us the closest output. But how can we get the computer to find the right values? And here, find the right values of W and B that matches the line. In this case, how machine learning works is just you start with W equals to 0, and then you try and find B, then check the prediction and the real data. If the results are too far away, well, you change W between 0 and 1 until you get the closest results to the data that you gave it. And now let's go towards the cost function. What is the cost function? Well, the cost function, its main goal is to minimize cost. As a human, it would have been very easy for you to draw the lines, but for a computer, you need a formula, and this is where our formula comes in. I'm not going to explain it in this presentation, but you feel free, of course, to go and have a look on internet. Now, let's dive into what neural network and deep learning is. The base theory of deep learning and neural network is to mimic how our brain works. It's inspired by the behavior of our biological neurons. Each neuron has a specific task, and we make them work together to get an output. And we use parameters. So what is a parameter? A parameter, it refers to the internal variables that the model learns during the training process. These parameters are crucial because they determine how the input data is transformed through the network to produce the output. So the aim of the computer is to find the best possible parameters to give you the best possible output. Let's take an example of how the brain works. Our brain has what we call different parts. We've got parts for vision, sound, language, and many, many, many more. And we use these to, like, for example, recognize a cat in this example. We call these parts layers, and a neural network works in the same way. Each layer will work together to detect that the image given at the start is a cat. So, remember the linear lines we saw just previously? We said that it was very easy to predict the output. However, the real world, as I said, is different, and it's complicated to properly represent the data. A deep neural network is a type of neural network with multiple layers between the input and the output layers. These layers are what are called hidden layers and allow the network to learn more complex patterns in the data. And backpropagation is the process of training a neural network by adjusting the weights and biases to minimize the prediction error. It stands for backward propagation of errors. Oh, I think my PC crashed. Okay, sorry. So, you might have heard about parallel processing and GPU to train your model. Well, parallel processing, it involves dividing a task into smaller subtasks that can be processed simultaneously rather than sequentially. It allows for faster computations by taking advantage of multiprocessing units working at the same time. And GPU, which means graphics processing unit, and it's a specialized processor designed to handle multiple operations in parallel. Originally, it was designed for rendering graphics in video games, and GPUs are highly effective for tasks that involve large-scale computations and matrix operations, which are very common in neural network training. Therefore, using parallel processing and GPUs speeds up the calculations. So, as a summary, what is deep learning? Well, it's neural networks with many layers really can be trained well if the weights are initialized in a clever way rather than randomly. And deep machine methods are more efficient for difficult problems than shallow methods. If ever you have any questions, feel free to put them in the chat. We will be going through them at the end of the presentation. So let's have a basic summary of what is machine learning and what we talked about. So we've got this diagram. We put user data and we train our model with machine learning. This is what we call training, which you can see with the arrow pointing down on the right of the diagram. At the bottom, we give in input data through the model to get output data, which is what we call inference. This is the main diagram to remember, and it's very basic to remember how machine learning works. But you have to be careful, as the data you put in to train your model can be very different from real-world data. Hence errors we can encounter when we use certain models. So do remember that the real-world data can be unpredictable. So, what is overfitting and underfitting? So overfitting, which is the rightmost diagram you have on the screen, it occurs when a model learns the training data too well, which includes its noise and outliers, to the extent that it performs poorly on new unseen data. This means that the model you have trained is too complex and captures random fluctuations in the training data rather than the underlying pattern in a way. So imagine that you are trying to predict house prices based on their size. You collect some data and you train a model. If you create a very complex model that tries to match every single data point perfectly, it's likely overfitting. And on the other hand, underfitting. It happens when a model is far too simple to capture the underlying pattern in the data. It doesn't learn enough from the training data and performs poorly both on the training and the test data. So using the same example of house prices that I just gave, if you use a very simple model, like a straight line, as you can see in the farmost diagram of the screen, it might not capture the true relationship between house size and its price. And it's even with the relationship being more complex. And what we're looking for is just in the middle, shown with the diagram in the center of your screen. So now, what are some Google products that you can use around AI and machine learning? Well, TensorFlow is an open source machine learning framework developed by Google. It provides a comprehensive ecosystem for building and deploying machine learning models. It's Google's open source library for machine intelligence. Then another one we have Carius, which is a high-level deep learning API written in Python that runs on top of other lower-level frameworks like TensorFlow. It was designed to be user-friendly, modular, and easy to extend. And to be more simple, Keras is one step higher of abstraction compared to TensorFlow. And finally, we have JAX, which is an open source library developed by Google Research that combines the ease of use with the power of automatic differentiation and hardware acceleration. It's Google's deep learning framework for cutting edge research. I will now leave Louis, which will be presenting the rest of this conference.
Thanks, Jack. So now we will talk about Google products on GenAI, which are the most used type of products nowadays, which are based on Gemini, which is the equivalent of ChatGPT of OpenAI in Google. And we will also talk about Vertex and Jet.AI. Let's go. So, in Google, we have AI optimized infrastructures, and off top of that are built Gemini models with Gemini Nano, Flash, and Pro. And on top of that, we have multiple products like AI Studio, Vertex and AI, and Duet AI, and we will talk about them. So Gemini is natively multimodal. We will talk about this just after. It has a sophisticated reasoning, and it is built for really advanced coding, like debugging, writing code, explain code, and all that. So, what does it mean that Gemini is designed to be natively multimodal? This means that Gemini can be used with text, with images, with audio, and with video in inputs and in outputs to have some really general AI. Gemini is built in three different sizes of models. Gemini Nano, which is for devices-based features like a Google Assistant, for example. Gemini Flash, which is the most basic Gemini model, which is used on the Gemini website, like a ChatGPT, which is also will be used in some projects like Gmail, Google Docs, and all that, like it was presented in the Google I/O some days ago, to have more features, like for Gmail, features like help with understanding mails, writing new mails, writing mails in some tone which is adapted to the person you write the mail, and all that. And Gemini Pro is for some more complex tasks, like for implementing in some more complex apps, like for example, an app that can organize a trip, for example. Okay, that's what he explained. Nano is for device tasks, Flash for the wide range of tasks, and Pro for highly complex tasks. You can also build Gemini-powered application. So for this, you can use AI Studio and Vertex AI. Let's talk about it. So Google AI Studio is a suite to fine-tune models, to test them with different parameters, different data to have it totally adapted to your own cases. You can try out different models, you can experiment with different prompts and export all those experiments, fine-tuning and all that in your code with an IPYK. So you visit the AI studio, you get your IPYK, you test some things, and when you have the type of model you want, you can export it in an app in Python, Go, Node.js, Web, Swift, Android, or REST APIs. For example, this is a basic integration in Python of the Gemini Pro model. So you can see it is really easy. And this is another example. You can have Gemini Pro API, which is optimized for text prompts. And you can also use Gemini Pro Vision, which is optimized for text, but also for image prompts. We'll now see an app example. This app is using the Gemini Pro API. You upload an image and the Gemini Pro API will use this image and describe it. So you have a total description of the thing you have an image. So yeah, that's an example of a use case. Now let's talk about Vertex AI. So Vertex AI is a machine learning platform that lets you train and deploy ML models on Google Cloud. You can customize large language models, code AI applications, and all that. Let's talk about it. So Vertex AI provides several options for training and deployment. First, let's talk about the two training options. You have AutoML, which is a really basic training option. You just throw some data, like image, text, video, or code, or some things, and it will just, without any coding or preparing data or parameting something, it will just train a model on this data, and yeah, that's why it's called AutoML. And after, you also have custom training, which is a more deeper way to train models. You can choose data format, you can choose some parameters, you can writing your own training code, and so you can have more power on how the training will work and what will be the results. Vertex AI also provides Model Garden, which is a garden to discover, test, and customize different open source models. And it also provides generative AI, which is the access to Google's largest generative AI models, the Gemini models. So you can use Gemini Nano, Gemini Flash, or Gemini Pro on your own application and fine-tune them with your own data to have a customized version of Gemini, which is really customized for your use cases, your application. So, what is the machine learning workflow? The machine learning workflow starts with data preparation. So you prepare your data for training. You choose what data is important for training and what data you don't really care to train your model with. After this, you have model training, and you evaluate the model and iterate on the training. You can, after this, deploy your model, and you can do monitoring, which is verifying in production what are the good and bad results of the model. For example, you can ask for users to like if the result of your model is good or not. And with this, you will have new data, then you will prepare, train, and etc. etc. So the Vertex AI workflow is basically the same. First, you gather your data, you determine what data is needed for train and testing your model. After you prepare this data, you format it, you label it, so it is really ready to training. After you train, you set parameters and you train your model with these parameters and data. You can evaluate this model with some of your data you choose for this, and you can after this deploy your model and monitor and start this again. So this is Vertex AI you can access by Google Cloud. This is the basic dashboard. You can use after this Vertex AI Studio. So this is Vertex AI Studio with all the different possibilities like language, vision, and speech. And for example, you can use Gemini Pro Vision, or Palm 2, which are the models developed by Google, but you can also use some other models that are open source, like EfficientNet V2, VYT, or SpyNet. And after you have chosen your model, you can choose a training method. With AutoML or custom training, you can define your model with parameters, choose the training options and the data you want to train on, and you can after deploy this using Google Cloud. Now let's talk about Duet AI, which is a tool for developers to help them during their work. So Duet AI is a AI-assisted development operations. It can also help with enterprise security, privacy, and IP protection, and it is powered by Google AI Foundation models like Gemini. So, for example, Duet AI can complete code, explain code, or suggest a test plan. So first, you can use Duet AI in Google Console Chat. So cloud can be really difficult to understand with a lot of products and a lot of parameters and all that. So you can use Google Console Chat to ask about products, informations, and to iterate a good infrastructure for your application in Google Cloud. You can also use Duet AI as a code completion, so it will help you as you type to write high quality code faster and stay in a flow state by proposing some code as you are writing. You can also chat in IDE, so you have some code and let's say you have some code, you don't really know about something, or you don't really know framework yet, and so you want to do something but you don't really know how to do it. You can just ask the chat to help you about this code. You can also use it for license attribution assistance. It can help you to choose good license and to stay compliant with the license you choose by real-time code license flagging via recitation checking. You can also use chat to explain code, like if you are working in a team, some people can write codes that you don't really understand or that can be really difficult to read and to understand, and it can be really quicker to just ask the Duet AI chat to explain the code so you can work directly. You can also use Duet AI for test generation because you know that when you code an application, you always need unit tests, but actually unit tests are taking really a lot of time, but not really hard to do. So it can be really a good way to have unit tests by asking Duet AI to write them to ensure a good coverage of edge cases without taking a lot of your time. So we covered Gemini, Vertex AI, and Duet AI. Thank you for your attention, and now we are looking for your questions.
Also, if ever any of you have missed any point that we made, this will be on the YouTube of our Google Developer Student Club channel, if ever you want to go and watch it again.
A really good question by Louis. What is your opinion about Devin, the software engineer? Do you know about it, Jack? No? So,
No.
what is Devin? Devin is an AI software engineer by the company Cognition, I think. That is the name. And so the idea is now we have a lot of models like ChatGPT, Gemini, and all that. And why do we need software engineers when those models can code? That's the idea. But actually, when we see the real state of Devin, which has been debunked by some people, it is really not the case that nowadays we can replace software engineers by AI. And actually, I don't think it will be the case for long years. So I think AI nowadays is really useful, like with tools like Duet AI to help you being really more productive. But I don't think the goal is to replace people. The goal is to have less people to do more work. Yeah, I think the project is really interesting, and I think it is a really good way by having this goal to develop some tools for software engineers to be more productive. But yeah, the video was faked, but yeah, the project is really interesting. Something to say about that, Jack?
Not at all. You just taught me something I didn't know about it, so thank you.
Okay. Some other question, remarks, something you want us to...
And also, the questions don't have to be with what we said. You can always suggest some conferences you would like us to talk about in the future.
Really good question. So the question is making AI with low-level languages still interesting despite all the new technologies running on high-level languages? So I think this question is like, yeah, new technologies run on high-level languages. Like, if you want to use TensorFlow, you will use Python. But actually, if you look a little deeper in the thing, tools like TensorFlow are actually C++, and when you use Python, you just use C++ code. Like it is easier to use it with Python, but in reality, you run C++ code. So I think it's interesting, but not for everyone. Like it is interesting to have people to work on it, to have good frameworks that have really a lot that are quicker and all that. But it is not interesting for everyone to work on that. Like I don't think the people that worked on ChatGPT or Gemini or all the Gen AI models really needed to do low-level languages themselves. But if no one had used low-level languages to code the frameworks they used, it will be impossible to have Gen AI. So it's important to have a development of AI in low-level languages, but it's not for everyone. It's two different teams, and I think it's good like that. Oh, yeah, that's a good question. Like, so it is possible to just use IPYs, or it is interesting to always have new models. I think that nowadays we see that having projects built on top of AI of with APYs or not really APYs, but that's the same is really something we do a lot nowadays. Like for example, Google in the Google I/O some days ago announced a lot of projects that are based on Gemini and but that are used for different test cases, like planning trips, like helping with writing mates, and actually it is possible to have a lot of innovative products based on a single model. So it's not really always the same model, you fine tune it and all that, but yeah, you can actually build a lot of different products that can be really actual innovation based on a single model with just the IPY. So yeah, I think it's not always useful to create models from scratch. It can be really interesting to have just a product built on top of different models that already exist just through some of an API. You're welcome.
Well, it seems that was maybe the last of the questions. Well, thank you all for coming and watching this live, and thank you for watching this on YouTube if you did, and have a great day.
Have a great day. Bye.